regarding these operations, as well as the plotting facility in MATLAB, how we can plot those results. So what is MATLAB? The first question is what is MATLAB? So basically MATLAB is a shortened form of matrix laboratory, and it is a high level programming language for numerical computation. And basically it was started for the matrix operation, but now it is having a very powerful and very convenient functions and tools available for data visualization. uh, I think most of the people who are working in the scientific computing side, no matter whether they are writing their code in C, C++, or Python, they actually finally come to MATLAB for plotting or showing the results. So it is actually very good, uh, I would say, package MATLAB, which uh, can be used for the data visualization, specifically for plotting the data and the curves. And those who already knows, I think some slides will be very elementary, because I am not clear about from where to start and where to go. There was no keyword given to me, but okay. So you can actually start MATLAB by various way. If you are working on a Linux system, you can open your Unix terminal and you type the command MATLAB, provided it is properly configured. You will get the MATLAB window popped up. Or you can use in Windows desktop, you click on the MATLAB icon, or you can actually press the window key in your Windows machine, and you just type in the prompt MATLAB, and then you can see that MATLAB, because in this machine MATLAB is installed, so you will be able to see MATLAB icon, and you can click it and you will get the MATLAB on your screen. I hope it will be coming soon. It takes time. And once you are having the MATLAB available to you, it will by default provide you the MATLAB command window, which will be open, and you can enter some of the commands and see the results. And there are many inbuilt command in MATLAB. For example, where displays the MATLAB version detail, what version of MATLAB in your machine you are having. You can use the command dir, which is basically directory. So it actually lists what are the items or content in the folder, in the present working folder. Then you can actually then you if you use any command, the output of the result will come either in the command window or the figure window, and you can actually tab change the different windows by clicking them. So for example, this is the MATLAB. Since I opened it, so I got, if you use this Windows key, and then if you type here MATLAB and you click, you will get this kind of configuration. So there are different kind of layout which you can choose. So by default layout is what I am using in this machine. I hope it is visible to you. Um, then as I said, that once you open it, you will get the command window. So there you can type some of the commands and execute them. As I said, where is one of the command which gives you the version. So this command gives us what is the version of MATLAB in my machine, and what is its license number, and various other things. If I put dir, so it will give me what kind of file and functions files are there in, or folders are there in the present working directory, which is called as PWD. So the present working directory is d/MNIT Jaipur. Basically, it is here. So your current folder is shown by MATLAB in this window, that is called current folder. And if you write something, you will get, if you are using some variables, we will see what are the variables. You will get your workspace and the variables also in this window. And as I said, you can actually change, you can go switch to one window to another window by clicking. And that's the thing. uh, then as once you have the MATLAB, you can actually use MATLAB for very basic thing, like you can do the MATLAB as a calculator. You can simply type in the command window the expression which you want. So this command window, you can see double forward uh, triangle, or I don't know what is the name of this forward sign, and this is the symbol MATLAB prompt. Basically, it is called MATLAB prompt, and here you can write your expression 2 plus 6 minus 4, and it will give you the answer. Uh, Sorry, 2 plus 6 minus 4, and it will give you the answer correctly. So you can use at a MATLAB as a calculator, and you can again in the prompt in the command window you can define the variables. For example, a equal to 5, b equal to 6, and you can add a plus b and you get the answer 11. So this kind of elementary task you can do in the MATLAB command prompt. And when you are if you see the things which we have done, the calculation which we are doing here. So what we are doing here, we are defining a as a variable name which contains, it's actually a container which contains the value 5, which store the value 5, and then variable b, which is again a container, and it is storing the value of 6. And when I'm doing the operation a plus b, I'm getting a new variable ans answer equal to 11. So this is a variable which is inbuilt variable. So there are built-in variables in MATLAB. So ans is the value, is a variable which stores the value of an expression when that expression is not assigned to a variable. So when you are not using any uh, like a user defined variable, then it will the expression or the evaluation will be assigned to the uh, built-in variable answer ANS, and EPS is again an inbuilt function or inbuilt variable which actually represents a floating point precision. It is called also called a machine precision. Basically, it is the smallest value in the MATLAB which MATLAB can distinguish. So if there are two numbers A and B, and if they are differing more than epsilon from each other, then MATLAB can distinguish both of the floating point number A and B separately. Otherwise, it will be same number for MATLAB. Similarly, you have a variable pi, real max. So all these are your inbuilt function. These are I would like to mention this n-argin and n-argout are special variables which determine the number of input argument, and n-argout determines the number of output argument. We will see this when we will talk about the functions. So basically, when we are talking about the input argument and output argument, we are talking about the uh, arguments in functions, and how you define MATLAB assign the variable. You can reassign, like, and you can use only built-in function on the right hand side of an expression. So basically, you cannot define a equal to EPS. Sorry, EPS. Sorry, right hand side. Sorry, right hand side. It cannot be defined EPS equal to 5. It is checking. I'm sorry. I think I have done mistake here. And there are two special built-in function, which is I and j, which represents the complex number, but we use them often for the looping, for loop and while loop. So they are actually represents a looping index also. And then there are some built-in functions in MATLAB, like log function is there, log natural log is there, log 10, base 10 logarithm is there, log 2 is there. So these kind of built-in functions are available in MATLAB, and we have some more functions like F0 functions. So there are many MATLAB functions which actually solves a lot of scientific computing problems, specifically finding roots of a given polynomial, or solving the first order or second order ODE, PD. So there are many functions. F0 is one of the functions which basically gives the value of x for which the function f is equal to 0, and it works for the continuous function. and all those functions which process the x-axis. And the basic syntax of f0 is x equal to f0, and then the function which you want to use, and the starting point x0. And you can have you can use this function f0 to find out the root of the given fun in a range like x lower and x upper. And this is the extended uh, syntax. So this is an example of inbuilt MATLAB function which is solving a root finding problem. So for example, if you want to find out the root of this equation or this function fx equal to x cube minus 5x plus 3, then you can define this f as using this expression. It is actually inline function. I will show you in my later slide how you can define that, what is the meaning of this. And then you just simply write root equal to f0 f1. So here you are passing the function f, and you are giving the initial value, initial guess 1, and then it will solve the problem, and you will get the root, approximated root 2.0946. And you can find out the another problem. I'm considering this problem. You want to find out the root of cos x in the interval 1 to 2. Then again it is same, like you define the function f, inline function f, and this is the syntax cos x, and then again you call the function f0, inbuilt function f0, pass the inline function f which you defined here, and give the range of the interval, and it will give you the root, which is actually approximately pi by 2. So similarly, there are many other built-in functions. So for the numerical integration, you have integral, integral 2, double integral. For double integral, you have integral 3. And for example, you can integrate the function sine x in the interval 0 to pi. So you can actually call the inbuilt function of MATLAB integral and pass the argument as shown in the above lines, and you will get the answer. So there are many inbuilt function. Then finite difference method also, for that also you have inbuilt function like diff and gradient. And for example, and it works actually for the discrete case. So you are having a vector x, and you are computing y for all those y equal to sine of x for all those discrete point x, and then you can actually compute the gradient of y. Then you have some symbolic integration and differentiation utility also available. So what I wanted to say that there are many inbuilt variables and inbuilt functions already available in MATLAB. You may not have to write or assign those values. So for example, if you want to use the value of pi somewhere in the calculation, you can directly calculate, use the variable pi which is there inbuilt. Similarly, if you want to use the machine tolerance, you can use the variable EPS. And if you want to solve some problems using like integration or differentiation, you can use inbuilt functions which are there. And the list is exhaustive. I'm just giving the snippet of the facilities which are there in the MATLAB. So once you start MATLAB, probably you will require a lot of help many times, especially if you are a beginner. And even uh, when you in today's era, actually you cannot rely on only on one kind of software or programming language. So sometimes you are working in MATLAB, or sometimes you are working in Python, and sometimes you will be forgetting about the syntax, or you may get confused the way I got confused, because you are working on the Python and you have some understanding, and that is not happening in MATLAB. Though there are a lot of places they are very similar to each other. We will see that also. I will tell when and as I will see the opportunity to tell you. So in order to take the help in MATLAB, you can use the inbuilt help utility of MATLAB. So the syntax is that you call the function help. Oh, you call the function help, and then give the name of the function for which you are seeking the help. For example, if you want to know how to use the function plot in MATLAB, you can type help plot. Or if you want to know how we can use the power function like 8 to power 5 or 8 to power 6 a square, then what is the way we can do, what is the syntax, so that you can type the help command with power as a function name. So for example, if you put help sign, so it will give you the details, a brief summary of about what this function sign does. And if you, and it also suggests you what are other possible things you which you may be looking for. So it gives you the proper suggestion, but it gives you a brief summary. And if you want further detail, you can actually go for the full documentation, which is there in the browser. So you have to write doc plot, and then it will be opening a browser, and it will show you the uh, uh, the details in the browser, and you can go through it. What you want, you will be able to understand after reading the documentation of the plot. And suppose you are looking for some function, you can use a command look for and then the function name, and it will give you possible of all. It will search first line of all functions and give you what are the things. So, for example, if you are putting look for cosine, so it will go and see the functions a cos, a cos, cos h, cos h. So basically, it will everywhere you have the string cosine in all these functions. So it will show you that these are the functions where you have the term or string cosine. So you can actually look again into those different functions in particular to find out what you are actually looking for. And interactive computing strategy means when you are using the command window, what are the things you can do and when you should use the command window for small calculations probably. So you can use the command window for quick calculations. So like I said, 2 plus 18. So this kind of quick calculation, if you want to do, you can use the command window, and you can test your small ideas and execute small operations within some functions. You write a function. I will show you. You write a function, and then you can actually cross check whether it is working properly or not using the command window. But if you are going for a full-fledged extensive the program, then it's always better to, yeah, to use editor and write scripts and build reusable functions. I will discuss that a little bit later. And there are certain things which are like practice, use practice, like you want, sometimes you want to, so when I'm writing a equal to 5, it is automatically giving my output a equal to 5, the answer. I don't want that. So a equal to 5, if I put with semicolon, I will suppress this output. This is one utility which you can do, because when you are writing a script where you are having so many assignments. So for example, for example, let us assume that we know how we can create a random number in MATLAB. So if I'm writing a equal to 5, I don't think so. It is giving me a 5 cross 5 matrix. But think about a problem where you are actually working with 50 cross 50 matrix, and if you don't suppress this output with semicolon, you will be in trouble, because your screen in the command window you will see a lot of text, and it will be a difficult thing for you to understand. Specifically, suppose you are defining two different metrics iteratively in your code, and each time whenever you are defined this matrix is coming, it will be showing you the output. So you can actually suppress the output. In this case, for example, I am defining a matrix a equal to, oh sorry, variable a equal to 8, and then I'm using the inbuilt function sqrt, square root of 73, and I have used semicolon to suppress the output, and then I'm defining c equal to log b plus a power 0.3, and then I'm not putting semicolon. So only the output of C will be popping up in the command window. Uh, this is a repetition. Yeah, it is a repetition. And you can actually in use multiple statement per line, so you can actually uh, terminate the output a equal to 5 by semicolon, then b equal to sin a and c equal to cos a. So then it will show you. So in the same line, you are actually assigning three different variables with three different values, and you have purposefully suppressed the output of assignment a equal to 5. So that you can do. And with this, like as we are saying that we are defining variable a, b, c. So what are the things which we can use as a variable name? So there are certain rules. So you have to start the variable name with the small letters a to z or capital letter a to z. And you may include uh, hyphen or underscore, and you can have at max 31 characters in your variable name. And one should not try to define a variable name which is already there in the list of variable built-in variable names. For example, don't use the word variable EPS, because EPS is already a variable, built-in variable in MATLAB. Or similarly, don't use variable name pi, because that is also there in MATLAB. Probably it won't give you any error when you are doing it, but if you are using pi somewhere else in your entire program, uh, maybe that will get affected, because there is a concept of local and global. So if specifically if you are using value of, if you are defining the variable pi as a global variable, and if you change the value of pi to 2 somewhere, and then pi is a global variable, so what will happen in some other functions, when you are using pi as 3.1456, it will be actually giving you the value, it will be using the value 2. So basically it will override the, the predefined value of pi. So that's not a good practice to use the name of variable as a built-in function. And these are some legitimate legal names. So like you can have all x or weight residual. So these are the example of variables. And one point which I wanted to mention, that it is MATLAB is case sensitive, like C language. So both the variable name length with capital L and length with small l are distinct for MATLAB. So if you are putting capital length with capital L equal to 5, and if you are using length with small length small letter L, then probably you are actually doing the wrong thing. It is not the value 5 which will be used. It will be using another value which is stored in length variable with starting with a small l. So with this, uh, we are coming to the input and output handling in MATLAB. So there are many various functions in MATLAB for the input or output. So one of the most important or usable of the self command which I use often is disp. So just it is called display, and then fprintf. Fprintf is printing the text in a formatted way, and then you have one more command called print, which is used to save the figure, not the text output. So for example, uh, you can use the input function to store some value in the variable. So for example, you are putting in the variable name, and you are using the function input, and the prompt is enter your name. So the user is entering its name. So the name of this user will go as a string, and it will be stored in the variable name. And it's optional basically. S is the optional. And if you are using the display disp command, then directly you can actually display. So x equal to 10, then you can actually format this way, this the value of x equal to, then you are using a function num to str, so number to string, and then you are putting x, so it will give you the value, the output of this will be the value of x is 10. And this is the most powerful output function in MATLAB. So the syntax of fprintf is a format string and the values which you want to print. For example, you have variable a equal to 7.89, then you can use the command fprintf, and we are putting the value of a is 0 percentage 0.2 f backslash n. So backslash n is a new line command, and then in this place the variable a value will be printed. So what is 0 point percentage 0.2? It is a specifier which ensures that two decimal places will be there in the output. So like if you are having a variable a equal to 7.89321, then if you are using this kind of specifier, then you will get only 7.89. The rest of the value will be truncated. So these are the things. Actually, fprintf is having much more utility, and I would suggest you that you go and see the documentation of fprintf. For our purpose, probably this is enough. At least for today's lecture, I think it is enough to know this. So here we are having this how we are using the print function to save a figure. So here we are defining a vector using the inbuilt command. So here x is a vector, y is a vector, and we are plotting. So like y equal to sine x, and we want to plot. And once the plot is done, we want to save the plot in PNG image. So this is the command, and one can actually do this in MATLAB. Even in the command window, you can do it. But as I said, like if you are going for a bigger code, then probably command window will not be sufficient. It will be quite difficult thing to use. So you yeah. Hello, am I audible?
Yes, 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 you are audible. Yes,
Sorry, there was generally doesn't happen, but this power cut happened.
yes, yes, yes. Now you are audible, sir.
So sorry for the inconvenience caused. It is generally doesn't happen, but it happened today. I don't know why. So we were talking about interactive computation and how we can use the command from command window to write small programs. But when it comes for the bigger program, it is not possible or advisable to use the command window, and for that you have to write scripts. And script, not only in MATLAB, in C or any other programming language, is nothing but a sequence of command which is stored in a file with MATLAB with .m extension. In C, it will be with .c extension. In C++, it will be .cc. And similarly in Python, it will be .py. So basically, it's a sequence of command stored in a file in the native language and store with the appropriate extension. So in MATLAB it is with a .m extension, and some places it is called M files also. And scripts basically help us to automate task calculations and simulations, and it executes command sequentially because we are writing a sequence form until we are not using some skip if else condition, and it utilizes the workspace variables also, and it enhances the efficiency in coding and debugging. And how you can actually create MATLAB script. So you just already we have opened the MATLAB script, and I can a MATLAB prompt, so I can use my editor. So in order to invoke the editor, I will use the command edit, and then I can use some name for my script. So my script, the name .m extension. When I create it, first time it will ask, it is not there, do you want to create it? Then you say yes, I want to create it, and then you can write here anything, display. Uh, this is my first script, like that, and you can actually, once you write this, you can actually save it, and then there are two ways to execute it. One is just to type in the command window the name of the uh, file or the script. So in this case, it is my script. File name is my script. So if you put my script, it is printing whatever you have written here. So a equal to and 5, and if you save it again, if you run, both the commands will run. So first it sequentially it is executing. So first it is executing this function, and then it is executing the second line uh, of the script. So this is the way you can actually create your script, and so this is what you are doing. You can do it. You can run it by this direct by clicking. So you have a button term like run, and you click it again, it will run. So I will show you. So it is showing this. So you can either run the program using the command window, or you can use the shortcut key button. So this is one example which I kept in my slide. So you just open the MATLAB script, and you are writing, you are assigning the variable, defining variable x, and you are assigning the value 5 in it, then the variable y, and you are assigning the value 10. So basically x and y are the container which contains the value 5 and 10 given by the user, and then you are storing the sum of these two numbers x and y into another variable called sum underscore result, and you are using the display utility, and you get this. So this is the script which is there in my command also. I think this is here, and if I run this, you get this. So this is your script and sum. So I can write here my sum, so that so it is first basically when you are clicking here, it is running in the command prompt itself, and then it is giving the output of the script, whatever was there, that whatever, not output, whatever was executed in script. So since we are using disp, it is giving the my sum equal to 15. If you don't want this, you can actually comment it and run it. So now you have in the workspace some of the variables. Let me show you one more time. So right now, if I, so I have this script which is summing the two numbers. If I click run, so in my workspace I have, it will show my variable y, x, and the variable sum result. And here you can actually type x, it will show you what is the value contained in x, value contained in y, and sum result also. So basically this is your workspace which stores all the variables which was used in your current script. And what is a function? So function is also a special kind of script. So for example, you are using doing some programming and you have a piece of code which you want to use all the time. For example, uh, suppose you are writing the code for Newton-Raphson function, and then in Newton-Raphson function you need to calculate the derivative of the function at every iteration. So at each time you are calculating the derivative. So the idea is that you write a piece of code which actually calculate the derivative of the function, and you just invoke that function, use that function every time when you need the derivative. So basically this way you will be ending up with a shorter version of the code and also a very neat code. So again, it is an M file, and it has its own workspace, and it is separate from those workspace, like from the main function from where you are calling it. And it enhances the modularity and code organization. So by default, the syntax for the MATLAB function is shown here in this snippet. So it start the function script will start with the keyword function, followed by a array or list of output variables. Then it will be having the function name, whatever function name you want to define. Then it will be having all the input variables, all the input arguments. And then you can write the comments on the function description, and then your original code implementation, followed by the and. So function file will always end with the keyword and. So for example, I want to use the square of a function. So basically I can write a user defined function like this. So this is square fun.m file name, and the structure of file is like function, then output variable y, then the function name square underscore fun, and the input argument x. So what this function does, it returns the square of the input variable. And again you go to the MATLAB command window, and you you define any variable a, and I have given here the value of a equal to 4. Then I am invoking the square function and passing the variable a, and square function is returning me the square of the variable a. So very trivial thing to understand. But let us see the code also, because I think I have what was the code? Was square fun. Square fun. This is your function. So I can here write an origin. So if I use a equal to 4, y equal to square fun a, you will see that y equal to 16 is coming, but here you are getting answer equal to a. So I can write a variable number of argument equal to an origin. Okay, it is a equal to an origin. Disp argument number of argument. If I put it like this, shall it work or not? So I think I have to see the display command. This sum. Okay. Sorry, I'm forgot the syntax. I hope it will work. So basically what I wanted to show here that we are using the inbuilt variable n origin, which is storing the number of input argument. So if I can put here, so this function is having only one input argument, so it is giving you number of argument is equal to 1. So that's it. I think it should be clear for you. If you have any doubt, you can ask me. So this is the MATLAB function example, and then what are the conclusion? Like you can use the MATLAB script, and it will be a sequential code, and functions help to organize the reusable code, and functions actually helps to loop the repeat actions efficiently. Then after that we have another set of utility called loops. So MATLAB actually has two different loops. One is for loop and another one is while loop. Most of the programming languages has those loops only. So for loop, what it does, it iterates a fixed number of times, and while loop basically it keep on continuing when the condition holds true, and it actually automates the repetitive task. For example, the the syntax for loop in MATLAB is given in this is snippet. Syntax is for index, then the start value and end value, and then whatever code you want to execute, and it end. So for example, in this case, I want to write the sum of first n numbers. So I have defined the first 5 numbers. So I'm defining n equal to 5, and then I'm defining a variable sum underscore result, and then I'm looping from 1 to n, and then I keep on adding sum result equal to previous sum result plus the number which is coming. So for first time I equal to 1, so sum result is 0. So once you are coming executing this line, some result will come 1, and again it will go to for loop, and this time I will take value 2, and it will come, then some result will be updated with value 1 plus 2, so it will be 3. So if you run this, so this line will keep on repeating for I equal to 1, I equal to 2, I equal to 3, and it will go up to I equal to n, and you will get the output in this case as 15. And a while loop has the syntax while, then condition, and end. So basically this condition can be truth variables also. I will probably show you somewhere. So again, we are trying to find out the factorial using while loop. So we want to find out the factorial of 5. So in this case, we are defining the factorial result variable, and we are initializing it the value 1, because each time it has to be multiplied with the value I, which I will keep on increasing. So we are starting with I equal to 1, and then we are putting while I is less than equal to n, then factorial result will be equal to factorial result into I, and then we put the increment in the value I by 1. So now, since I equal to 1, initially I equal to 1 and equal to 5. So is this true? So 1 is less than equal to 5. Yes, it's true. So this line will get executed. Then it will go to the next line. The compiler will go to the next line, and it will execute this line. So I has initial value 1. It will be added by 1 more. So now after the execution of this line, I is equal to 2. Again, it will go and check whether 2 is less than 5. Yes, then again it will happen. So it will happen up to 5. And after that, once I equal to 6, it will go and check 6 is less than equal to 5. Answer is no. And then it will terminate. And then the answer will be stored in the factorial underscore result variable, which you can actually display this way, and you will get the output 120 in this particular case. Then you have conditional statements in MATLAB. So you have different conditional statement: if else, and else if, and switch case. So if condition is, it will execute if condition if the condition is true. Otherwise, it will go to else. Again, it will check for some condition. So basically, it's a conditional statement. The example is here. The syntax is like if condition, code executes if condition is true. So for example, checking if a number is positive. So x equal to 10, we have defined a variable x equal to 10, and then we are using whether this number is positive or not. So we are putting if x is greater than 0, it will display x is positive, and. So if will always followed by and, or always followed by else, and else if, and. So those things are there. For example, this is another thing. So if followed by else if, then and. So in MATLAB, all the loop and conditional statement will start with the keyword if or for or while, but it should be supplemented with the and. So ultimately it has to be there. So for example, in this case, you are classifying a number x equal to -5, and you just want to show whether the number is positive, negative, or 0. So you are using this if else if. So if x greater than 0, it will show x is positive. But what is happening here? We have defined x equal to -5. So it will show, it will, if, so this condition is not met. So this piece of code will not get executed. Then it will go to directly, the flow will go directly to the else if. And again, it will check this condition. X is less than 0. Luckily, we are having x, the value of x equal to -5. So it will be, it is, the condition is met true, and this line of, this piece of line, or this line of the code will get executed. So in this case, if you run this code for the value of x equal to -5, it will give you the answer x is negative. So this is the syntax and the basic use. One of the quite a good feature in MATLAB is switch statement or switch condition. So the syntax is that you have a variable, so you define the switch, you use the keyword switch, follow it, like, and the variable switch, and then you use the variable whatever you have defined. Then you can have case value 1, case value 2, otherwise and. So if you have the value of the variable is value 1, then it will execute the code for value 1. Otherwise, it will execute the code for value 2, or otherwise default case. Sorry. So for example, we have a variable day, and we are assigning the value as a string Monday. And now we are using switch function. Switch function, and what is the argument followed by, like, switch function is using the variable day. Now you have different cases. So case 1, if it is Monday, then you display start of the work week. If it is Friday, then display weekend is near, otherwise regular day. So since we have defined the variable day as Monday, the value we store in the variable day as Monday, if you run this code, you will get it as start of the work week. And these are the small things which was related with the loop and if else conditional statements. But as I said, MATLAB is basically for the matrix laboratory. So it has very powerful tools, very efficient tools for the matrix manipulation. And it is actually makes MATLAB a quite popular uh, software for most of the people who work in scientific computing. Uh, those who are not working with very big data, because their MATLAB has some storage issue, but otherwise for normal scientific computing, MATLAB is really very good. So in MATLAB, as I said, it has lot of operations. So let us see what are the matrices and vectors, how we define them in MATLAB, and how we can use them. What are the operations we are having in MATLAB for the matrices and vectors? So by default, in MATLAB, all variables are matrices. So when I say that, what it means, a scalar is a matrix with one row and one column. So scalar is a one cross one matrix. Similarly, vector is a matrix with one row or one column. So either it is one cross n or n cross one. Either it is row vector or row matrix or a column matrix. So we use the terminology differently, but it is like this. So this is also a vector. So 1D vector is a vector, and 1D matrix is a vector. And if you, I'm not talking about the strings MATLAB, but strings are also row or column vector of characters. And we can actually apply the rule of addition, subtraction, and multiplication. Basic as a calculator, I have shown you, but we can add two vectors also of n dimensional, or two matrices also directly, element by element, and we'll see how we are going to do that. And if you have a vector x, uh, you can actually point out or you can address the second element of that vector as x and a small bracket 2, and similarly the ijth element of a matrix A can be represented as by, as like, for example, if we want to address the element of at index 4 and 5, then you can actually use within the small bracket 4 comma 5. So these rotations are clear from the context, but can be confused with the function call. So for example, you are here, x is a vector and you are indexing with the value 2. Here sqrt is function with the second of this. Okay, and this is f is a function. So if you are putting f equal to f,
Professor Ritesh,
yes,
yeah, sorry to interrupt you. Sometimes your voice is breaking. I think, if possible, you can switch off your camera so that audio will come clearly.
sure, sure. That's a
Yeah.
good suggestion. Let me check how to switch off the camera. My camera.
There is a button, start video and turn off video.
So here it is. I'm not able to see it here. In the where it will be, anybody can tell me?
There will be a
My
button.
screen is visible.
Yeah, screen is
It is
visible. Yeah. Screen is visible. Earlier it was off.
video setting is there. Okay. So stop sharing. It is
Uh,
showing my
there,
screen.
there is a button, video, start video, turn off video. The video button would be there. It's near to share button. It's just beside to share button.
Just beside to share button.
Yeah.
I'm okay, let me check. Okay, now I got it.
Yeah.
Stop video. Shall I continue?
Yes, please. Now your voice is very much clear. Please go ahead.
Okay. Okay, where I am. Okay, I think yes. So we were here. So if f is a function, then this meaning of this in f3 is that the value 3 passed to function f. If f is a vector, then we are calling the third index or element of the vector f. And how we can define matrix and vector in MATLAB. So very simple. So for example, if you would want to define the matrix A, which is a 3 cross 2 matrix, and you want to define a column vector X with the length 4 and V as a row vector, that you can actually define the matrix in MATLAB by separating the rows entry by white space or small comma. So 3 comma 2 or 3 space 2. So you want to write the row 3 and 2. So you just separate the 3 and 2 by white space, or you can put a comma in between them. And whenever you are completing the row, you can actually terminate the row by semicolon. Then the next row. Again, this time 3 white space 1, then semicolon and 1 4. So basically, each row entry will be separated by a white space or simple comma, and each row will be terminated by a semicolon. Similarly, each yes. So if you do this way, then your matrix A will be a 3 cos 2 matrix. Depends. So we are having actually first row 3 2, second row 3 1, and third row 1 4. In case of X, because you want X as a column matrix, so what that means, each row is having only one element. So each element like 5, again terminate the row 5 first row by semicolon, then put value 7 in the second row and terminate the row by semicolon. So like this you can actually define your column vector, and row vector is as well, like you just write in the square matrix. I forgot to mention that you have to use this square matrix notation in the MATLAB to define matrix or vector. So this is the way you can actually define. Then there are operations. You can actually manually define. So the way we are defining is manually, and I think this is in square. This is sorry. I think it's repetition. I think this is repetition. This is the transpose. So once you have created the vector or matrix, you can do certain operations on that. So for example, in this case, we have defined the row vector 2 7 1 4, and you can actually find out its transpose by using the single quote or apostrophe. So then you get, so your V is your row vector, and then W is going to be a column vector. Similarly, you have a matrix which is defined like 1 2 3 and 4 5 6, very simple matrix. Then if you want to take the transpose of matrix, you simply write B equal to A apostrophe or transpose. You can, once you define a variable, you can actually change the variable value also. So for example, y is your vector, and this is again repeating here, x equal to 2 x, yes. So this I have covered. So you can basically, what is happening here, you have defined x equal to 2, and again you are updating or adding 2 into the variable x, and there are special functions to create matrices and vectors in MATLAB, and in many times when we do the computation, they comes really handy. For example, linspace and log space, they are the bin-digit function. Similarly, you have very special kind of matrices like ones, zeros, diagonal matrix or tri-diagonal matrix, which comes in solving your partial differential equations. So you can generate those matrices very easy by using the built-in function. You will see. So you can actually use linspace function, and you can use linspace function, and it will give you a vector. So the default argument is like you put linspace, the start value and the last value. So what it will do, it will partition the interval x2 minus x1 into 100 points by default. Otherwise, what you can do, you can provide the argument n, means you want n points between x1 and x2. So it will partition only into n partition. And then if you put suppose, you will get a column. So when I am writing linear space 0, 9, 4 means I want to divide uh, 4. I want to generate n points between 4 points between point 0 and 9. So first point will be 0, then 3, 6, and 9. So 4-point equidistance point has been generated by this, and then apostrophe will give you the column. And again, we are using the transpose here. So x is equal to this space, and then y equal to y. We are defining as exponential of the column vector x because we have taken transpose, and z equal to log x, and then we are creating a matrix. And since we are not assigning it to some new variable like a equal to big bracket x y z, automatically the display will come. So you are having the x equal to linear space 1 to 10 into equally like 6 parts. So you get these values. So 1, 2, 3, 4, 5, 6. So 6 part. So 6 division has been done between 1 to 10, and then you are taking the exponential, and it is a vectorized function. Exponential and log, all those functions are vectorized. So instead of like you can pass a scalar value as well as a vector value into this. So when you are passing x as a vector, you will get the y also as a vector, and the shape of input vector and output vector will be same. This has to be noted down or keep in mind. And if you want to create matrix, there are some special matrix like matrix of zeros, matrix of ones, and the syntax is like number of rows, like the keyword ones, then the number of rows and number of columns, and rows and calls. Similarly, you can create the matrix of zeros and rows and calls. And if you are doing like this 3 cross 3 matrix of 1, you have to invoke the command once, and you will get all one matrix. Similarly, here you are getting 2 cross 4 matrix of ones. Similarly, it's a row vector of ones, and it is 0 vector of a 0 column vector.
Professor Ritesh Kumar Dubey, sir.
Yes,
If you allow us, can we take a break of 5 minutes?
yes, yes, it's okay.
Yeah, yeah, because 1 hour has already been passed. So candidate those who want to go for some water and other things. So generally after 1 hour we are taking a break only for 5 minutes. Then you can start your lecture again.
No problem, no problem. You just let it be like this, or you want me to close the thing?
No, no, let it be like this, just for 3-4 minutes break, and then again you can continue.
Okay, okay.
Okay.
You
Okay.
just prompt me when you want to start. I'll also go and take water.
Okay. Sure. Sure. Sure, Professor. Yes, Professor Ritesh, we can start.
Okay, just let me share the screen again. Is it visible now?
Yes,
Hello.
yes, it is visible. Yes, sir, it is visible.
Okay. Okay. I think I'm there also. Hello. Yeah.
Yes, your voice is audible. Yes, you can start.
So we were talking about the functions to create matrices, and we talk about the ones and zeros functions, inbuilt functions in MATLAB, which creates all one vector or all one matrix or all zero vector or all zero matrix. Then, as I said, you have a diagonal matrix. So suppose you want to create a diagonal matrix, very simple command is there in the MATLAB with the term name I. So if you put I and if you give the argument any value n, then you will get n cross n matrix. The syntax, the extended syntax is like you are giving the number of rows and number of columns, and you will get the identity matrix. So, for example, if you put C equal to I5, what will happen? It will create a 5 cross 5 identity matrix and store in the variable or container C. And if you give the second argument also, and then you can create actually non-square matrix. If you put 3 3, then it will be a square matrix, but you can actually put 5 and create non-square matrix. And in this case you will be having a diagonal matrix but sub-diagonal matrix. It's not like it will be a, block diagonal, like this kind of structure. First, see, it will be a 3 cross 3 identity matrix followed by 2 columns of zeros. And basically what the you can actually implement it by using for loop by your, and you can put like dij equal to 1 whenever I equal to j. So this is the basic definition of diagonal matrix. And you can actually use one of the facility which is there in the MATLAB called reshape, and it will reshape or resize the matrix or vector into matrix, or matrix into vector. So for example, here we have defined vector a equal to 1 to 8. So basically, I will talk about this column symbol again. But what it means, like it is giving you the start value and end value, and in between you have the by default increment. So it is by default increment is 1. So you are going to get vector a as 1 2 3 4 5 6 7 8. Then since it is a vector of length 8, we can actually reshape it into a 2 cross 4 matrix, and that's what we are doing. So this, the only limitation is that you cannot randomly put 3 comma 4, because the size of the vector should be matching with the size of the matrix after reshape, like should not be different. And so this is actually very good utility in MATLAB. It is there in Python also. It is there in the most of the deep learning APIs also. You can use a function called diagonal v and diagonal a. So what it does, it creates a matrix of a diagonal matrix with the given entry. So for example, you have a vector v with the entries 1 2 3, and you want to create a matrix a with the diagonal element 1 2 3. So you can use this command diag v. And if you have a matrix, then you can actually use this to extract. The same command can be used to extract the diagonal of matrix and store it in a vector. So for example, here you have a matrix B, which is a 3 cross 4 matrix, and when you want to put extract these diagonal entries 1 6 11, then you can use this command w equal to diag b. So what it will, this command will do, it will take the matrix V and extract the diagonal 1 6 diagonal element 1 6 and 11 and store it in W. So this same function one time is being used to create the matrix with the diagonal entries defined by or given by a vector, and the same function is used to extract the diagonal entries of the given matrix. And you can actually assign or reassign the values of any matrix. So, for example, you have this matrix A, which is actually 3 cross 3 matrix, and you can define a variable B, and you can assign this variable B with the third and second entry of indexed entry of the matrix A. So, third row and second column, so which will be 8 in this case. So, you are assigning the third and second indexed uh, element of matrix A into B. And similarly here you are assigning the first element of the matrix A in first row and first column. So this is the way you actually do the indexing. So Aij denotes the ith row and jth column element, and you can actually use this indexing to reassign the value of a matrix value in the particular element of a matrix. So for example, you can use a11, so you can provide this new value 0.25. So if you see here it is 1, now it is 0.25, rest of the entries are same 2 3 2 3. So you can actually use indexing to assign the value or change the value of any of the entries of a matrix. And if you refer uh, to an element beyond the dimension of a matrix, then you will get the error. This is one problem. So, and the command, if you do this, for example, here your matrix is 3 cross 3, and if you want to address the element 1 4, then it will give you the error because here the dimension 4 is bigger than the dimension 3, and it will show the index exceeds matrix dimension. Of course, if you assign an element beyond the existing dimension of a matrix, then the matrix will be resized. So for example, again you have matrix A, 3 cross 3 matrix. If you take an element 4 comma 4, so basically both the dimensions are beyond the size of the initial variable, initial matrix. So it's 3 comma 3. So we are putting 4 comma 4 equal to 11. So what will happen? Our matrix A will be resized, and you will get this new matrix where this entry, the new entry will be 11, and corresponding entries in the array, corresponding row and column will be 0. So basically what it is doing, it is resizing the matrix on the fly when you are writing the code. So now we come to the column notation, which is actually one of the most powerful notation or most powerful functionality in MATLAB and in Python also. It is one of the most powerful utility. So what is the syntax and in what sense we take it? So basically, you take a start value, put a column, and then put end value. So what will happen? It will create a vector with one increment from start value to end value. So let us see. Let me check. So I am putting here a equal to 3 to 6, and I am not putting semicolon. I don't want to suppress the output, so we'll get this. So now you can see I'll get the index values 3, 4, 5, 6. Okay, I can do something else also. I can define my increment also in this case. Again, start value and end value. By default increment is 1, but now I want the increment something else, so I can define 3 and I can give the increment 2. So I should be getting, I can see this, so I'll get 3 and 5. So 3, then after 2 increment I'll get 5. After 2 increment I will cross the end value, so it will not come. So I am having 3 and 5. So this is the syntax. So it can be used as an operator also and also as a wildcard. So operator means it defines the ranges, loop, and indexing. So like if you are, as I said, a equal to 1 to 2, 10, it creates a row vector from 1 to 10. And if I write b equal to a 2 to 5, then we are actually extracting element number 2 to 5 of vector a, and we are storing it to b. Let me show you this in the command prompt. So I'm giving a equal to 1 to 10 and b equal to a 3 to 5, and you will see b is equal to 3, 4, 5. So I can extract only these three values. If I put 3, 2, 9, then we can extract 3, then 2 jump, then we will get 5 increment, then again 2 increment, we will get 7, and then 9. After this is the end value. So we are stopping here. But if I put here 8, what will happen? We will get 3, 5, 7, because after that there will be no increment. 7, 8 will, one more increment will go beyond the end value. So this is one way. And what is wildcard? Basically, you can actually use it as a placeholder that selects all elements there specific dimension. So for example, let us define a matrix A equal to random 5. I have not discussed this in my I can write here 3, 5. Maybe it will not. So I am having a random matrix of 3 cross 5 size, and I am writing A colon 4. If I want to see this, I am writing B equal to A colon C. So what I am doing, take all the rows in the fourth column. This should be the answer of, these are the values. This column should be stored. So you can see first column comma 4. So first entry shows all the rows, and this is the number of or index of the column. So it is showing you assign the value of fourth column into the vector or in the variable b, which is column vector. Similarly, you can actually do this way. If you are putting 1 colon 2, no, 1 comma column, that means you are taking first row and all the columns. So I can put here C. So you can see this. So I'm taking all these values. So this is the space holder, wildcard as a placeholder. So this is one of the utility. So whenever we want to, and it is called slice operator in Python. You are slicing the vector, and here like two examples I have already shown you in the MATLAB. So like s equal to 1 to 4, then t. Yes, this is the point to be noted that we are not forced to choose integer value in the start values and end values. You can use also a non-integer increment also. So start value, increment, and end values do not need to be integers. Now you can create the column vector also. This using this column notation 1, column 2, and then apostrophe. That is transpose. So you get a column vector. And sometimes people do get confused and they put this kind of index 1 column 5 transpose, and it will give you again a vector, because 5 is a scalar number. If you take its transpose, again it will be 5. So basically writing v equal to 1 column 5 transpose is equivalent to writing v equal to 1 to 1 column 5. So it will be a common mistake by most of us. I also did when preparing this slide. So it can be avoided. And wild guide explanation and examples I have shown you in the MATLAB prompt window or command window, sorry. And so I can skip it here. And this is also, as I told, that we can use it as slicing operator. What we did earlier, that is also slicing, like we are slicing here. Previous, it's not there, but we were slicing it. So like we have created one matrix A of ones from of 8 cross 8 size, and now we want to slice it, this 4 cross 4 entries as 0. We want to put assign. We want to assign these all ones to 0. So you can actually use this slashing operator. So what it is doing, take the, so like before comma, whatever you are putting, you are putting for the row, and after the comma, whatever you are putting for the column. So what you are doing, take the row from 3 to 6 comma, then take the column from 3 to 6 and put all those value equal to, so basically it's a 4 cross 4 and sub matrix from the matrix A, then you are putting equal to 0 as 4 cross 4. So the dimension should match both the side. Whatever sliced matrix you are having on the left hand side should match with the dimension of the value which you are entering. So this is one thing which you can do, and this is simple. Like you have a row vector, you can, if you are doing this way, you can convert it into column vector. Similarly, you can convert a matrix into a column vector. Okay, rand function I'm using. Now this description is here. The rand function generates random elements between 0 to 1, repeating the preceding statements. So if you keep on changing the, if you keep on calling the random function, every time for each call it will be different vector or matrix. So a equal to rand 3 5. Then again if I call, I'll get different values. So it's a random number generator, and it is generating the randomly value between 0 to 1. I think the standard deviation, yeah, it is normal variable between 0 to 1. Is standard deviation, I don't know what it is. We can actually find help, right, and probably will get. So it is, it can give you the details. I think it's not the right time to look for the details for me. And now we come to the addition and subtraction. So in the scalar case, we have seen 4 cross 6 or a plus b. We have done a equal to 5, equal to 2, and then we did a plus b, and we got 7. But that same thing can be done element by element with the vectors. So you can actually add 2 vectors. You can subtract 2 vectors of the same size. You should have the same size vector u and v, and you have inner product and outer product notion in mathematics. So you can define them. So mathematically it is defined like inner product of u and v, and it is defined by u v transpose, and the outer product is u transpose v. And MATLAB, you can actually define u transpose v u star v transpose and u transpose v. So those things you can do. So in this case, you are getting a scalar value. In this case, in the outer product, you are getting a matrix. So inner product will result into a scalar, and outer product will result into a matrix, which is very simple also, like you can see. And it is actually an example of vectorization. So what is vectorization? Basically, it enables efficient computation by applying operations to all vector element without explicit loop, leveraging MATLAB's optimal kernel. And it provides a high level compact expression for calculation, improving code clarity and performance. So most of the build function does this. And if input is scalar, the output is scalar. If input is a vector or matrix, the output has the same dimension. So I have given previously also, like when we put x, y, z a matrix, and we shown x was a random number, and then y was exponential of x, and z was log of x, and then we shown. So there we did the same thing. So here again we are actually uh, defining the vector, row vector between 0 to pi with increment pi by 4. So it is the value which you are getting. If you take the cos of this, you will get same vector of size, same size of same size vector, and the value of uh, output will be stored in y. And you can actually multiply with a constant to the matrix, and you will get the, in one go, you will get all the output. So pi will be multiplied directly with 1, 2, 3, 4 in one shot. And when you are writing sine A, so what will happen? Sine of each entry of the resulting matrix A will be calculated. When you are writing B equal to A by 2, all the entries will be divided in one go, and these are the outputs. And actually, it is very efficient way of doing this. You can do it using for loop also, but that is computationally very costly, specifically for the matrix, because you have to go two for loops, and the complexity will be very high. So how we can actually do this multiplication, vector multiplication, element by element? It is also called canonical product. And uh, basically, you have notion of called operator overloading. It is a concept from the OOPS. So here we are seeing the glimpses of the operator overloading. So you have by default in matrix defined symbols for multiplication, division, and square of power. You just put one dot. So A dot star B means you are multiplying A and B element wise, and A dot square means you are putting the square of element by of each element of the matrix A, and it is nothing but the operator overloading from the loop. So, for example, if you have vector u and v, you can multiply w equal to u dot star v. So you are having vector value, and it is directly 1 into 4, 2 into 5, and 3 into 6. And you can actually do the division also. So u by 4 equal to 0.25. If you go and without dot backslash or forward slash, then it will not, it will give you the error. So dot forward slash represents that you are talking about the vectorized division. And same, I think is true in this case. We are defining z equal to pi star u by 2 dot forward slash cos pi star v by 2. Pi is your inbuilt function, so it is nothing but the pi function. And since there will be a instance where the value of the denominator will become 0, it says that it is not defined. So you have n, not a number. It will show you this. And in matrix also, same way you can actually do this operation, element by element multiplication. But if you directly do this A star B, it will not give you, because the dimension mismatch will happen, because it is 2 cross 4 and it is also 2 cross 4. So you need to have, but if you are doing this, use the second dimension of matrix A and the first dimension of matrix B should match. It is not the case in this particular example. So it will not go through, it will throw an error. So this is the example, and you similarly you can actually do this power square of the matrix A element by element, and here we are taking transpose to do the matrix multiplication, normal matrix multiplication. Here it is a element wise matrix multiplication. Here it is a normal matrix multiplication. So this is not possible. So we have taken B transpose here, and that can be defined this way. But it is different from the element by element uh, matrix multiplication. And after this, one important function. Actually, there are many things in MATLAB. I cannot cover everything, but whatever I felt that I should cover, uh, I'm doing that, keeping tomorrow's lecture in mind. So one very important utility in MATLAB is the inline function. So basically, you can actually uh, define a function inline, and then you can use the function repeatedly. So it will be a quick calculation without storing function in separate file. So you don't want. So basically, you write functions files to do certain task. But if the task is very simple, just one line, then you do not have to really write a new function. You can simply write this inline function. So it is it comes very handy, and you don't have to store a separate file for doing that. So for this, it is a it's a small helper function, and it is what do you call it? A parallel of this utility is there in Python also. I think in C, I don't know whether it's there in C++ or not. So, but in Python it is very much there. So the syntax is very simple. You use the variable f, any variable, like here it is f, and the syntax is like at the rate symbol, and then whatever the arguments you are having, and then the expression. So for example, you want to define a function x square plus 3x minus 5, and since you want to do it a vectorized fashion also, so you are just putting dot square 2, and x is your symbolic computation, or x is your variable. So what it does, this line, what it does, it defines this function x square plus 3x minus 5, and then you can actually pass the argument directly. So for example, in this single variable case, same function we are doing. So when I'm writing f2, I will get the value of function x square plus 3x minus 5 at x equal to 2. And when I'm want to do this multiple variable, we can do this also. So g equal to at the rate x comma y, and here you are x square plus y square, and then you are putting the value 3 and 4, and you're getting the answer 25. If you take the square root, probably you are talking about something called the radius of a matrix. You can actually think that way. So for example, you want to calculate the radius of the matrix, you just simply use this small function rather than writing a separate function file. You can use the inline function. This is the purpose of this, and you can use the inline function in the MATLAB functions. For example, you want to find out the root. I discussed in the beginning f0 function in MATLAB, which what it does, it finds the root of a given input function argument with respect to, or taking the initial guess 1, here in this case 1, and it gives the root. So that is what we are doing. We defined the inline function f, and now we are using the f0 function to find this inline function's root with the initial guess 1. And same way you can actually define this inline function f, and you are integrating this f from interval 0 to 1. So mathematically, basically what you are doing, you are integrating from 0 to 1 e to power minus x square. Yeah, so that can be done, and you will get the answer. So for example, you can use inline function in plotting also, and here we have using f plot. I will come for plotting in next slides, but here we are talking about the f plot. So f plot is basically takes continuous function over a specified range. So first we define the inline function sin x, and then we are calling f plot function, and we are passing the inline function here, and then we are providing the range, and automatically it will be taking x values for smooth plotting, and this is the plot of that function. So if you put these two line in the command prompt, you will get this. So let me check here for defining inline function f at the rate x sine x. So my function f is defined, and then I can write f plot f comma 0 comma 2 star by, yeah, we got my. So this is the way you can actually do this. So we are passing inline function in f plot also. So inline function is good when you want to do a task repeatedly, but it is a one liner only. So there are certain restrictions also. That's why we go for the writing functions. So it cannot have multiple lines of execution, cannot include loops or conditional statements, and it is best suited for simple mathematical expressions. And for complex logic, you use a separate function file. use function keyword in M file. So basically this I have discussed how you can define. And if you want to really explore more, you can actually go to this MATLAB documentation of anonymous function. For anything, you can go for the documentation from the MATLAB. And one of the beauty of MATLAB is they have given the very beautiful documentation, very elaborate documentation for each and everything. And also it has a very active forum for question answers. So you can put questions. In fact, most of the time you may not be requiring to put your queries. You will see that most of the time it is already asked by somebody and answered by somebody else. So you can just take the solution for a problem over the self from those forum, and then that brings me to the last part of my today's lecture. It's plotting. So as I said in the beginning, that plotting is one of the most you know, uh, liked feature. In fact, I like it very much, MATLAB plotting, because it provides you a lot of freedom also, especially after plotting, saving the plots in different format, and then you open it. And in fact, MATLAB has its own .fig format, which help us to reopen the plot and annotate it, modify it. It's called post processing. It's very easy there. So you have a different type of plotting, like XY data is there. You can do the access scaling and annotation. You have features for 2D plotting. You have features for 3D plotting, and so there are simple syntax. So you have, if you want to plot x and y data, so simple by default is plot x and y, and it will be give you choose the simplest form of the plot. Then you can actually define x and y, and you can give the symbol also if you want a different type of plot. You can actually do the plotting for multiple variables, like x1 plot of y1 with respect to x1, plot of y2 with respect to x2, and then symbols. So there are many different sentences for this. For example, you just write x equal to space and 0 and 2 pi as we shown. So it will create some 100 points between 0 to 2 pi, and then it's x is a vector of that size, and then you are calculating y equal to sine x. Sine is a vectorized function, so you can pass a vector x and it will directly give you vectorized value y, and you can directly plot it, plot x and y. And basically this is very simple, but you can actually add different kind of features into your plot. You can have dashed line, you can put some square, you can put some circles, and those details are given in MATLAB documentation. I have taken something from the net. So you can choose the color of the plot, like line. So y means yellow, m means magenta, c means cyan, and r equal to red, green. Then you can choose the symbol also, whether you want point or circle or X marks or plus marks. There are many more. Then similarly, you have symbols star, S means square, D. So basically, you have all these colors into uh, columns, and all these symbols available for you to put in your MATLAB plot. And then you can actually line type also you can choose. Line style means you want solid, dotted, or this, and you can also choose the thickness of line. So for example, if you are using plot x comma y, and you are putting yo, means you want to use yellow color, and you want to use circle or dot circle in the plot. And if you want to use red color annotation or a red color line, you can put r minus. And if you want to put black line with dash thing, you can do this. You do not have to really know all these things. You can actually do many things interactively. I'll show you maybe towards the end. And there are different type of functions which help us to do the plotting. So like log plot is there. So you can log y versus log x with the base 10. Semi log x, so basically linear y, and logarithm 10 of x. Similarly, log 10y versus linear x. So these kind of things you can do. So you can either hard code the plot annotation or type of the plot or the type of marker or line size in the code. You can do the hard coding that there, or you can first draw a very normal plot and then do the post processing. I will go through one. I'll try to do something towards the end of this slide presentation. Then you have a, if you want to put multiple plot in one figure, then you can actually use this syntax subplots, number of rows, number of column, and this plot. So basically what it does, so you are having you want 4 figures in a plot, so you will add 2 comma 2, so 4 figures. So basically it is basically a matrix which you are generating 2 cross 2, and the first image, then the second image, then the third image, and then the fourth image. So you have generated here x vector, then you are plotting x with sin x, and you are taking axis from in this domain. So domain is, so axis is a command which actually after plot it will put the axis this way. I will show this, and then you are putting title. So you plot, you can rearrange the axis, you can define the axis, x domain and y domain, then you can put the title, then again subplot 2 2. This is the plot number, this plot is the plot number, and again you are using the axis and subplot 3. So when you are doing this, so you will get sin x, this is the title, and this is your domain axis, sin 2x, sin 3x, sin 4 by x. So this way you can actually get the multiple plot per figure. And this is a 3D plot. So in order to create 3D plot, I am using inline function. So I have defined a two-dimensional inline function, which is nothing but sin x into cos y plus x square minus y square, which is defined here. And in order to create mesh grid for 3D plotting, we need to use the mesh grid function, and that can be done different way. So what we are doing, first argument is linear space. So we are defining linear space vector, like vector from -5 to 5 with 50 equally spaced point, and the y direction also from -5 to 5, 50 equidistant grid points, and then it will give you the mesh grid. So basically, you have taken this and you gotten a net of 2D net, and where each point in each direction you will have 50 points, and then you calculate the evaluate the variable z for every x and every y, and you get the value of variable z, and then you can actually use the surface plot. So surf is a command to do the plotting. So what it takes x and y, which you obtain by the mesh grid function, x and y, and the z variable. Then you can put the x label, y label, z label, title, and color bar like this, and it will give you this plot, which you can actually do post processing also. And one more good thing about MATLAB, that it provides you latex support, so you can actually convert your titles. For example, in this case, this is the title 3D plot of x and y in the code. So after doing this, I change this into function, what function we are showing. So for that, I just use the latex engine of MATLAB. And there are many things which you can use, like plot annotation. So access, so we can reset the access limit. So here, if you see, they have, in this case, access limit is all set from 0 to 2 pi in x direction, and this is minus 1.5 to 1.5 in y direction, y axis limit. And this is what all about the plotting. It is a quite a detailed topic. but I think I'm done for today. Let us see. It is very easy also in MATLAB. I will show you something. I don't know what to. So you have a code example integration. I can. Okay, I'll just show you this. Okay, let us see my plot example. I think the code is not here. So I will write here edit my plot dot m. So I'm creating a new edit script for creating plot. So x equal to minus 1 0.11 vector x and y equal to sine pi star x. Then I'm putting plot x comma y, and then I can run this and I'll get my function. Okay, so I think I should take it. I should take this 0.1 and run it. So I'm getting this kind of plot. Now it is very raw plot, and I can do a lot of things in this by going into the plot figure properties. So once you open the figure properties, you can interactively change and see what you want. So for example, I want to change this line from blue color to red color. I can choose. It will become red, and I can actually put the line width. I can make it 2. So line width will be changing. I can use marker also. So far, right now there is none. I can add marker. So it is showing like this. I can do many other things. For example, I can go here and I can put insert x label x axis x axis. Then here I can put y label also y axis. Then I can put here the title, the plot. I can put sine pi x. This is the way we can write, but it doesn't look good because mathematically it's pi x. So I can go back and I can write here in the dollar sign like latex, and then I can do like this and go here again. I go here in figure properties and I can choose for this uh, interpreter as latex, and you got sine pi x. So then you have, so there are a lot of utilities which you can use in order to change the plot. You can use those things to modify. All the things are very very interactive. That was the beginning. I started with the interactive computation. So when it comes for the plotting, you have a lot of things. In fact, you can find out the value of x and y. So this is called like you can see the values. So this is you can put data tips. So you can have the data tips also for different points. So I think probably you understand the, uh, the power of MATLAB, and especially when it comes for the post processing the plot. When you have more than one plots, then it actually becomes much more important to choose different markers and line type and colors in order to distinguish them from each other. So I think I'm done for today. If you have any questions or query, you please go ahead and ask me.
Thank you, Professor Ritesh, for a very, very wonderful and very informative talk and lecture about the MATLAB different tools. You have covered almost all the tools and the programming functions of the MATLAB in 2 hours lecture. It was not an easy task, but the way you have delivered all these things. I'm sure that the participant must have got all the ideas about the MATLAB, so that in the next lecture tomorrow or in the coming days they will be able to solve all the numerical problems, whether it's numerical integration, differentiation, difference operators, and other things. They can easily make the codes using MATLAB tools. Thank you, Professor Ritesh Kumar Dubey. So, if participants have any question, they can write in the chat box.
I don't know where. Check. Okay. Some questions. Thank you, sir.
So, if you do not have any question, then you can write the no question.
They Samir Prasad is asking, rotate with respect to X. I don't know what it means. Maybe something I'm not able to follow. But they are saying thank you to me. I think they mean that I am completing the talk in time for that.
Uh, yes, yes. So if there is no question, then let us again thank to Professor Ritesh Kumar, sir, for a very nice talk. Sir, on the behalf of the organizing committee and on my personal behalf, I am very much thankful to you for interacting with our participants of the FDP and delivering such a nice lecture about the MATLAB.
Thank you.
Uh,
Thank you.
yeah, sir. I have one more request. As a part of our FDP, all the lectures has have to be uploaded in the PDF file on the Canvas platform, so that those students who have missed anything, they can again go through the slides. And even the all the lectures are recorded also on YouTube channel, and the link for those recording is will also be made available to the participant through the Canvas link. So, sir, if possible,
Yeah,
you can send me the PDF file of your lecture, so that I can ask my assistant to upload your lecture on the Canvas.
yeah. I will do that. But for the video, like we got a lot of interruption today. So you are going to do the fine tuning, or you are going to put them as it is.
I think, sir, it is recorded as it is by the YouTube, and the MNIT has subscribed some YouTube channel. So we have our other staff for this. They will see it, and I think they will do whatever is required, and then they will upload the link of this YouTube channel.
Yeah, I would suggest you that you can remove that break part. You can remove certain things which are like internet connection loss or voice issues. So those things can be like before loading. It should be edited properly. So then it will.
Yes, sir. I'll ask my assistant to do that also. They will see where, if there is any interruption, they can cut that part, so that the
Yes,
smooth
yes.
video would be uploaded. And through your Canvas platform, you can also see all these things, sir. And you can also see your recorded video in the Canvas platform.
Thank you, thank you. I will send you the slides.
Yes, yeah, the PDF version of your slides.
Sure, sure. Thank you.
Okay. Thank you, sir. Good day. Bye bye. So thank you all the participants. Now I can close this session, and we will meet tomorrow again at 10 a.m. And within half an hour, you will be getting all those things on the Canvas platform. Whatever you have missed, Satyendra Prasad, no issue. It will be there on the Canvas platform, recording as well as the PPT. Whenever in the evening or any other time you get the time, you can go through the recorded lecture as well as the PPT. Okay, thank you. Thank you very much, all the students and the participants and the faculty members. Thank you. Good day. Bye bye.